Hi everybody, and welcome to exercise 3 on page 40 of the workbook. Here's another example of finding the equation of the tangent line to a function. Okay, we did an example like this earlier in this section. Let's just kind of review the steps in this. Okay, so we want the equation of a line. Okay, so ask yourself, what are the pieces of information that you need to find the equation of any line? Well, the key is to find a point and a slope. Okay, if you can find those two pieces of information, you've got enough information to write the equation of the line. And let's start with the slope part of this. How do you find the slope of a tangent line? Well, by definition, the slope of the tangent line is the derivative. So that's going to be our first step here. Take this function and find its derivative. Notice that the function has a bunch of powers of x. So if we start with x cubed, that's x raised to the third power. Its derivative is going to be 3x squared. Again, power rule just says we're going to bring that power 3 down and we're going to subtract 1 from the exponent. Okay, and then we've got a minus 2. That's a constant. Now we need to take the derivative of x squared. By the power rule, we're going to bring the 2 down. We're going to subtract 1 from the power, so that's going to be 2x to the first. And then we've got a plus 4 times x. So let's see, 4, we'll just rewrite that. And then x to the first, remember that x can also be rewritten as just x to the first. When we take its derivative, we're going to get 1x to the 0. Okay, and then finally the derivative of the plus 1 at the end is going to be 0. Okay, let's simplify this a bit. So we're going to get 3x squared minus 4x plus 4. There's our derivative. Okay, but to get a slope, we need a number. And so the idea is to use the fact that we want the slope at a specific value of x. X equals 1. So we're going to take that 1 and substitute it into our derivative and see what we get. So let's see, that's 3 minus 4 plus 4. That looks like it's going to simplify to 3. Okay, and so we have figured out that the slope of our tangent line is 3. Okay, we're halfway there. We've got our slope. Next thing we need is a point. Okay, and we can find a point on our tangent line by using the fact that the tangent line is going to intersect the graph of our curve at x equals 1. So to find a point, we're just going to substitute 1 into our original function. Okay, that's the formula that we've got up here, and see what we get. So if we substitute in 1 for all of those x's, let's see, what's that going to give us? 1 plus 2 plus 4 plus 1. That looks like 8. Oh, wait a minute, I'm sorry, I made a sign mistake. This should have been a minus here. Let's fix that. All right, so actually it should be 1 minus 2 plus 4 plus 8. What is that really equal to? Looks like that's going to be 4 now if we simplify that. All right, so what we did is we substituted in 1 and we got out 4, so we know that a point on the line is going to be 1, 4. Okay, so we're ready to write the equation of the line. It's going to look like y equals mx plus b, and the m is actually this number right here, the slope. Okay, so we're going to get y equals 3x plus b. And to figure out what the b is, we're going to use the fact that we know a point on the line. So when x is 1, y is 4, we'll go ahead and just substitute those two numbers in and see what b is. So let's see, that's going to be 4 equals 3 plus b. If we subtract 3 from both sides, we're going to just get b equals 1. All right, and so the equation of our line should just be y equals 3x plus the b that we just found, which is 1. And there's our answer.